Okay, just to be sure that you have some examples, and we've talked about everything that you have to do. I want to just kind of remind you. So we have from the section on linear patterns and rules. You're going to have a chart with some values, right? Where they're going to give you some number values. They're going to give you some of them, and you're going to have to fill in the rest, right? So all you have to do again is just establish the pattern, and then you're good there, right? Okay. Then they're also going to give you some where you have the rule. Remember, the rules always look something like this. That's an n, by the way, 2n plus 3. And you have to tell what the 25th number is. How would I do that? 25 in place of the n, and do the math, right? Remember that? So that's just plain substitution. Okay? All right. Then you're going to have to write a rule. If you have a list of numbers, and remember to write a rule, you use that difference method. First, find the difference in the t's. Right? So that will equal your common difference. So like if it was 5 minus 3, you get a 2. 7 minus 5, you get a 2. So 2 is your common difference. So remember that already automatically gives you the first part of the thing, right? Then, test. And when you test it, always test it with the number 1 for n, because it's the easiest one to use, and see if it fits your pattern. So say, for example, my pattern was 7, blah, 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 blah. I don't care. So 7, plugging in 1 there, t times 1 gives you t equals 2. Is 2 what I wanted? Nope, I wanted a 7. What do you have to do to a 2 to get it to be a 7? Add what? 5. So that means my pattern should be 2n plus 5. Right? Very simple process, but make sure you know it. There's a lot of them. Writing the rule. There's another writing the rule. Here's one where they want you to write the rule, then find the 29th term or something. Okay. Here's one where they give you the rule. And yeah, you're not supposed to see this. I'm looking at the test, so you're not going to see these.
Why do you say?
Pardon me?
Then you were saying it like
Oh, I'm just saying, yeah, here's one. Or there's one. I get it. I see what you're saying.
Can we use a calculator in the test?
I'll have to check. I'm not sure. You used a calculator on the last test, didn't you? Yeah, on the measurement one. So I'm not sure.
But that was because it was heaps of weird numbers.
Now, I'm not sure. I'll have to check. Now, one of the things that we didn't really focus on, but I know you've seen in your problem solving, and it does occur on the test, is one like that. That one where you had where they told you what V was, right? And so that one was a little bit different in that you have to solve it. Right? Because they didn't tell you what T is, they told you what the other number is. So that means I have to get this thing all by itself, this T. So how would I move this add 20? Remember you just do the opposite? Yes. Right. So we'll subtract the 20 from both sides. You're just doing the opposite. So you got to undo the addition. And this is what we're going to cover in our next section. And what does 10t literally mean? What operation is holding those two things together? Multiplication. And the opposite of multiply is what? Divide. Now these were in your homework. I just didn't notice them. And so we didn't talk about them. So t equals 1. Okay. All right. Be aware that those could show up. All right. And that's the problem solving. Y'all did this simple equation, balancing an equation, I think is what y'all called it, right? When you did the problem solving at the first of the year. So it's not new to you, okay? All right. Now, but what if I told you I wanted to know the, let's see, a number value of something, a number of something? Then pay attention to whether you're talking about like the third means that's the n number, right? Okay? But if I told you the number was 512, then that's the t value. Remember the difference, right? So if you see like third, second, you know that those are always the n values, right? The number set. Okay? All right, let's see. Then moves right into the after those are the only ones I'm really worried about you because we didn't go through some specific homework on those because y'all didn't want to. Then the Cartesian plane. Remember you have an x and a y value. X tells you how far to move either right or left. Y tells you how far to go either up or down, right? Okay? So make sure that you can pick the values for a point. Also, if you have a bunch of points in a chart, you can plot those. But just remember, so like you have 2, 5, 3, 7, whatever. 2, 5, which one of those, so if you're just looking at this point there, which one of those is the x and which one is the y?
Would 2 be the x?
2 is the x, 5 is the y, right. So that's to the right 2 and then up 5. Right? Remember when you're plotting on the Cartesian plane? So to the right 2 and up 5. Okay? All right. So you have to be able to do those. Then you're going to have to fill in the chart using the rule. Fill in the chart using the rule, then graph it. Okay? Drawing lines. Plot. You fill in the chart, then draw the line. Okay. Yes.
For things like if there was a graph about say like water filling up in a bath or something, and they give you the points on, or you have to fill in the chart, doesn't really matter. Then if they give you a full Cartesian plane, would you extend the line before 0 as well?
Yes, but on a problem like that, they wouldn't. But if they give you a full Cartesian plane and you're drawing a line, yes, that line should extend all the way. Okay. If it's something that they give you like that one where the amount of water in the tub can't be negative, right? So that's what you're saying. Should you extend it there? No, but it'd be very unusual for them to give you a graph like that. But I guess they could. So like in this one, for example, let's say this was the amount of water, the number of liters. Okay? If you move over here, then that means the number of liters is negative. The time would be negative. So you can't move down here where the liters would be negative. You can't move into time and liters can't be negative. So if you had a graph, then your line couldn't exist there, is what she's asking, right? Because you can't have a negative time and you can't have negative liters, can you? Okay? All right, but if you did have time and liters, let's say this was 10 liters and this was 20 minutes, right? And you had a line, and I wanted to know at what time was there 10 liters in the thing. All you have to do is go across to the line at 10 and then go down and read the x value, right? So if you know the y value, read across and then down to find the x value. What if I knew the x value? So what if I said that the time was 20 minutes? Find the 20 minutes, go up to the line, and then go over there to find out what the y value is, right? If you know x, that means you're looking for y. If you know y, that means you're looking for x. Yeah? Make sense? Okay. The next ones are all about the gradient. Remember, gradient is rise over what?
Run.
Oh, some of my little year 7s didn't get that right yesterday, and I wanted to strangle them. Rise over what?
Run.
There you go. So you count from any point up and then over. Now, if they've already drawn some lines, it doesn't matter. You can use their lines, but remember that they always do the run first and then the rise, which is fine, but then you've got to make sure you put them in the right order when you do the math, right? What if you get 4 over 2? Is that good enough? 4 over 2 means 4 divided by 2, which would give you a gradient of 2, right? So make sure you reduce any fractions. Okay? Find the gradient. Just calculate the gradient, it says. Interpret the gradient. And explain. What does it mean if it's doing this? The gradient is what sign? It means it's going up, right? Gradient means positive. What if it's going down? Gradient is negative. And so if you remember the ice cream one, the line was going down. That meant we started off with a lot of ice cream and what? Ended up with none, right? So over time, we ate up all the ice cream. You got rid of all the ice cream, didn't you? See what I'm saying about describing it? Okay. Negative gradient, that means it's going down, right? So say you had negative 4, down 4 and over 2. That would give you a gradient of negative 2, wouldn't it? So what's your signs? Okay. And so negative gradient means that you're using it up, going down. All right. What's the y-intercept? Sure. Go ahead.
The point where the line first touches the y-axis.
Right, where it crosses the y-axis. So if I have this line, then that point where it crosses the y-axis is the y-intercept. Right? What's the x-intercept?
The line crosses it.
You bet. So the point it crosses the x-axis. Okay? Remember, if you're at the y-intercept, that's where x has to be 0, doesn't it? Because you can't go right or left any. And at the y-intercept, the x-intercept, y has to be 0 because you can't go up or down any. So you also know the y-x values at those intercepts. Okay? Remember that when you have that y equals mx plus b, or plus c, y'all use c. What is m? The gradient. You don't even have to do any math, right? You're just reading it. What is c? The y-intercept. And so if I know those two things, that's enough to be able to graph a line. Y equals 3x plus 2. That means my y-intercept is 2. So go up 2. My gradient is 3 over 1 because I have to make it look like a fraction, even if it's not. So just put it over 1. So that means go up 3 and to the right 1. And there's my line, right? So you're going to have to be able to graph from an equation. And they're actually going to tell you, find the gradient, tell me what the y-intercept is, then graph it. None of this, do it in your head and counting and hoping for the best nonsense. Okay? All right. All right. Then here's one where you have to answer a question about a gradient. Okay. What if I tell you to find the value when x equals 5? Then you just look at the line where x equals 5. Let's say x equals 5 right there. Okay. Then go up, find the line, move over, find the y value. Right? So some more of that. Okay. This is known as finding the solution, right? So you can solve an equation. So if x equals 3, just find 3, go up to the line, move across, find out what that y value would be. And that's the solution. Remember that? Okay, several of those. Okay. There's also one on there that came from the Extra from Experts things where you have two lines. And they want to know where they cross. what could you do? Or you two equations. Graph both of them and find the point where they cross, right? So it's a little stretch because that we didn't talk about too much, but it's there. That one has ice cream in it. If you're doing looking at different values, like the cat is this tall, probably not. Cat is this tall, dog is this tall, right? And you're comparing their heights and ages. And remember comparing heights and ages? Okay, that kind of thing is on there. Then there's like height with age. Maybe the ice cream one. Okay. You need to be able to tell that as one thing increases, something else, what? Decreases, right? So say, for example, I have time and money, and I have a line like this. What could you tell me? As the time, what? Increases, the money also increases, right? What if I had time and money went down? As the time is still going that way, right? So the time is still increasing, but the money is going what? Down. So it's decreasing. Okay? All right. You're going to be given a graph, one of those, all over the place, like a travel graph, and you have to find out where's the gradient steepest. Right? Now, does steepest always mean up? Nope. Steepest means steepest. So it could be somewhere where it's down or up. Okay? Writing the equation of a line, if you're given the gradient and the... I don't want to use them. So say if I had m is 2 and c is 5. Can I write the equation? Sure. Y equals what? 2x plus 5. Just plug them straight into the formula. This is looking as easy as that test I gave you, right? Hopefully. Okay. All right. So find the cost of something by reading the graph, find time by reading the graph, and then the last one is you have to graph something. Now, be careful. Remember that when we had one of those distance ones, those distances could be negative because they're talking about a specific place. Like let's say you're walking from the train station and you have to pass, and I want to know when you get to Freedom Furniture. But you didn't start at Freedom, did you? You started at the train station. So you started before that, and so it could be negative, right? So you can't have negative in that case, can you? So be careful. Okay? So those travel graphs, graphing one of those. And that's it. If you can do that, then you should be able to blow this test away. So now you have a little bit of an idea of where you need to concentrate on if you think. And all of them, again, came straight from the homework from Education Perfect that I assigned to you. Okay? Good.